Ever stop and think about water? We use it all the time. We drink it, bathe in it, wash our clothes with it. And yes, we flush it down the toilet. But what happens to that water after we're done? It goes to a wastewater treatment plant. These plants clean our used water. They work day and night. Their job is crucial for our health and the environment. Imagine if we didn't have these plants. Dirty water would flow into our rivers and lakes. Wildlife would suffer. Wastewater treatment plants transform dirty water back into clean water. Alright, so the wastewater has arrived at the plant. It's traveled through a network of underground pipes, sometimes for many miles. This water isn't pretty, it's carrying all sorts of debris. The very first step in cleaning it up is called preliminary treatment. Think of this as the bouncer at the door of a club. Its job is to get rid of the really big, obvious troublemakers. The first part of preliminary treatment is usually screening. Imagine a giant heavy-duty kitchen strainer or a rake. Wastewater flows through these screens, which are made of metal bars. The bars are spaced to catch large objects. We're talking about things like sticks, rags, plastic bags, wet wipes, and sometimes even lost toys. After the big stuff is screened out, the water moves on to grit removal. Grit includes things like sand, gravel, coffee grounds, and eggshells. These materials are heavier than the organic solids we want to treat later. How do they get the grit out? Usually, the wastewater flows into a special tank called a grit chamber. The speed of the water is slowed down just enough to allow the heavier grit particles to settle to the bottom. This preliminary stage really sets the scene for the more complex cleaning to come. Once the big objects and the heavy grit are gone, the wastewater moves into the next phase, primary treatment. This stage is all about letting things settle down. The main goal here is to remove a good portion of the suspended solids. Think of it like this. If you stir up mud in a jar of water and then let it sit, the mud will slowly sink to the bottom. Primary treatment works on a much larger scale using the same simple principle, gravity. The wastewater flows slowly into large circular or rectangular tanks called primary clarifiers or sedimentation tanks. The water needs to be calm and still for several hours. This gives the suspended solids enough time to settle to the bottom of the tank. As these solids accumulate at the base, they form a layer of what's called primary sludge. While the heavier solids are sinking, lighter materials like grease, oil, fats, and plastics float to the top. Mechanical arms or skimmers slowly move across the surface of the water, collecting this floating scum. This scum, along with the primary sludge, will go on for further treatment of its own. After primary treatment, the water is already noticeably cleaner. However, the water is still far from being safe. But primary treatment has done its job, preparing the water for the next, more sophisticated stage of cleaning. Now we get to the really clever part, secondary treatment. This stage is all about biology. We enlist an army of tiny living organisms, mostly bacteria and other microorganisms, to do the dirty work. These aren't bad germs, these are the good guys. Their job is to eat the dissolved organic matter that's still left in the wastewater after primary treatment. These microscopic helpers are nature's recyclers, and they are very efficient at breaking down pollutants into simpler, less harmful substances. One very common method for secondary treatment is the activated sludge process. The wastewater from primary treatment flows into large aeration tanks. Here it's mixed with a concentrated soup of these helpful microorganisms. This is the activated sludge. Air is bubbled vigorously through the tanks, or the water is churned up to mix in oxygen. These good bacteria need oxygen to live, breathe, and munch away on the pollutants. They feast on the organic matter, growing and multiplying, effectively cleaning the water. After spending several hours in the aeration tanks, the mixture of water and microorganisms flows into another set of settling tanks, often called secondary clarifiers. Just like in primary treatment, the water slows down, and the microorganisms, now clumped together in heavier particles called flocks, settle to the bottom. The rest of the sludge, now called secondary sludge or waste-activated sludge, is removed for further treatment. Even after secondary treatment, the water might not be quite clean enough for certain situations, especially if it's going to be discharged into a sensitive river or lake, or if it's going to be reused for things like irrigation. That's where tertiary treatment comes in. Think of it as the final polishing stage, the detailing on a car wash. It's an advanced level of treatment designed to remove any remaining pollutants that primary and secondary treatment couldn't quite get. This can include very fine suspended particles, specific nutrients like nitrogen and phosphorus, and any lingering disease-causing organisms. One common tertiary treatment method is filtration. The water is passed through filters made of layers of sand, gravel, and sometimes anthracite coal. These layers trap the remaining fine particles, making the water even clearer. More advanced filtration methods like microfiltration or ultrafiltration using special membranes with microscopic pores can remove even smaller particles and even some bacteria and viruses. Sometimes specific chemicals need to be removed, particularly nutrients like nitrogen and phosphorus. Special chemical or biological processes can be used in tertiary treatment to target these nutrients. The final and very critical step in many tertiary treatment systems, and sometimes at the end of secondary treatment, is disinfection. The goal is to make the water safe before it leaves the plant. Throughout the wastewater treatment process, from preliminary screening to the clarifiers, we've been removing solids. All this collected gunk, the stuff screened out, the grit, the primary sludge, and the secondary sludge, is collectively known as sludge. And there can be a lot of it. We can't just ignore this sludge. It needs to be treated and disposed of properly. Sludge treatment is a crucial part of running a wastewater treatment plant. The first step is often thickening to reduce water content. Sludge can be very watery, sometimes more than 99% water. Thickening makes the sludge less voluminous and easier to handle. This can be done in gravity thickeners, similar to sedimentation tanks. Other methods include dissolved air flotation or rotating drum thickeners. The goal is to get a more concentrated, thicker sludge. Next up is often digestion. Microorganisms break down the sludge. Anaerobic digestion is common, where bacteria work without oxygen. This happens in large tanks called digesters, often over several weeks. After all those stages of cleaning, preliminary, primary, secondary, and maybe even tertiary treatment, the water is finally ready to leave the plant. This treated water is called final effluent. It's a world away from the dirty wastewater that first arrived. It's much cleaner, clearer, and safer. But what happens to it now? Well, there are generally two main paths for this water. It can be discharged back into the environment, or it can be reused for various purposes. The choice depends on the level of treatment it received, local regulations, and the needs of the community. The most common way to handle final effluent is to discharge it into a nearby body of water. This could be a river, a stream, a lake, or the ocean. Before this can happen, the treatment plant must ensure that the effluent meets strict quality standards set by environmental protection agencies. These standards dictate how much of certain pollutants can be present in the water. Regular testing is done to make sure the plant is complying. The goal is to protect the aquatic life in the receiving water body and to ensure that the water is safe for other downstream users. So, we've taken a journey through the wastewater treatment plant. We've seen how dirty water full of all sorts of unpleasant things gets transformed. It goes from being a potential hazard into something much cleaner, safer, and sometimes even reusable. It's a complex process involving big screens, settling tanks, armies of helpful microbes, and sometimes even advanced filtration and disinfection. It's a testament to human ingenuity and our understanding of science, particularly chemistry and biology. And it's happening every single day, in towns and cities all over the world, mostly out of sight and out of mind. But why do we go to all this trouble? Why invest so much effort and resources into cleaning up our used water? The answer is simple, yet profoundly important for our health and for the health of our planet. The big splash conclusion on clean water's importance. So, we've taken a journey through the wastewater treatment plant. We've seen how dirty water, full of all sorts of unpleasant things, gets transformed. It goes from being a potential hazard into something much cleaner, safer, and sometimes even reusable. It's a complex process involving big screens, settling tanks, armies of helpful microbes, and sometimes even advanced filtration and disinfection. It's a testament to human ingenuity and our understanding of science, particularly chemistry and biology. And it's happening every single day in towns and cities all over the world, mostly out of sight and out of mind. But why do we go to all this trouble? Why invest so much effort and resources into cleaning up our used water? The answer is simple, yet profoundly important, for our health and for the health of our planet. Untreated wastewater is a major threat to public health. It carries bacteria, viruses, and parasites that can cause serious diseases like cholera, typhoid, and dysentery. By treating our wastewater, we prevent these diseases from spreading through contaminated water sources, protecting ourselves and our communities. Clean water is a cornerstone of public health, and wastewater treatment is a critical part of that foundation. Beyond human health, wastewater treatment is absolutely vital for protecting the environment. When untreated sewage enters rivers, lakes, or oceans, it causes severe pollution.